Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And, this week we're going to get into full automation versus hybrid automation. We're going to kind of dig into that, and also kind of look at how you can be compassionate when you're bringing in these type of systems as far as how do you promote from within. I think some of the stuff that we've seen, is kind of, how do we balance good with bad, but how do we kind of make it worth it and have a little bit of fun with it. But, before we get too in depth, we got Cham back with us. And the one thing that we're going to want to go over is, we didn't get your opinion on the last 2 weeks worth of last two topics that we had.
Yeah.
The first one being test cell development.
Yeah.
And then 3D printing for robotics.
So start off with test cell. I think we kind of talk about test cells or testing or training in some capacity already every single time we talk about anything cobots or anything like that. So at the end of the day, we have I think we're all on the same page. We all believe a test cell or training cell is necessary. It's going to teach you all of the things that you need for any other difficulties, problems that you're going to have implementing, production issues, anything like that. It's going to show you how to train your robot, your cobot, things like that. But I think it's vital to have a test cell just in general, just the thought of an area of, if you're trying to implement something, how can I validate the logic I'm going to put in versus am I just shoving a system in that's like turnkey, so to speak? So in a lot of cases, nothing's going to be really turnkey. Everybody has a specific application. So if you don't have a training cell, you're not really planning for success.
Yeah, I can see that.
So I mean, that's the biggest thing that I kind of would harp on as far as the test cells and things like that. Now, setting them up, I think that it makes sense. You have to have, not only do you have to have safeties, like extra safeties, because you're going to be working with these things, but it should also have the ability to simulate failures. And I think that in a lot of cases, a test or training cell is, how do I make things go right, and not always what happens when they go wrong. So I think that it just throwing a test cell isn't also the solution, but you have to kind of like a curriculum. You have to say, okay, well, if you don't do these things, this will happen. But then also on-site or hands-on training of, oh no, we just broke something or the machine's clapped because I didn't program it right. Those things would be vital to be included. But then the other piece, so I don't want to harp on it too long because we want to keep going. So the second thing was 3D printing support with cobots, if I'm not mistaken. Mm-hmm. I think we've talked 3D printing
with robots completely. It's either
just completely with robots.
Either
so I think we've talked about this kind of like here and there.
For robots.
Oh, you mean so printing parts, attachments, hose clips, things like that. So, okay, I can see these things are vital because your upkeep, and we've already talked about like logistics parts, small parts manufacturing on site. Mm-hmm. Like we've talked about it. If I'm building a van or a car or any type of vehicle, you need a robot to manipulate. It's heavy. It's a big item. But there's a lot of little gaskets and a lot of little things like that you have to buy in large bulk. But if I have 300 vans, why would I buy 5,000 to 6,000 of these gaskets? Yeah, I plan to make more of these vans, of course, but if I'm only making this set amount, I can have a printer gear that amount out so that I have it as just in time is something that a lot of companies and manufacturing places like, because it's less waste and you're getting everything in more exact quantities. So 3D printing for support for robots, you need to be able to upkeep your robots, period. So small batch printing makes sense. You need to be able to iterate and make little tiny improvements here and there. So maybe your gripper's not precise. Maybe the piece that you now are working with is, a 1/4 inch thinner, or not as, the diameter is not as big. So you have to consider these things. So it's the rapid iteration of 3D printing, and the fact that you can also 3D print with metal in several different fashions, just makes it like, it makes sense. I mean, you can get a couple robots, and you could have one robot be full production, the other one be your robot printing the parts to repair, preventive maintenance, and a hot swap. That to me is how a lot of systems would work, because if, let's say, your first one breaks, you hot swap the second one in, and now you have your repair robot fixing the first one while the other one's producing. Yes, you're in a state of risk during that, but I mean, you can't alleviate or remove all risk. So I mean, these are big machines. These are high temperatures they're welding at. If they're welding, if they're printing, it's still high. It's like upwards of 500 degrees Celsius. You don't want to be there. So
you don't want to be touching it.
I'd rather the robot do it. So yeah, I mean, the support for it, I think that it goes hand in hand with just having them. If you're doing preventative maintenance, you should probably have something along the lines of anything that can print parts, reprint pieces. Maybe that machine that robot's 10, 20, 30 years old. You don't make those parts anymore. The best way to make it is with a 3D printer. So,
okay. I mean, that's kind of what Haas doing with their subtractive
and the melt IO system,
or additive/subtractive technology. But
yeah, I got no doubt that there's probably many other people that are thinking of or trying to solve the problem as well.
But it goes to what you were saying. They're actually using it, like, say, somebody breaks a gear somewhere. They're actually using that in that type of application, where they replace the gear by making it in house instead of having to wait 6 weeks.
I think the first example of that I realized was vital for 3D printing is they welded like a mixer, like a giant paint mixer, and this thing is like the size of like a truck with like a long bed, and it's a big mixer mixing like a vat, like a giant container of paint or some type of material. I couldn't remember. I remember watching this on How It's Made or something along those lines. But they used to mill those parts, they'd have to have a giant piece of metal and subtractively like take pieces of it off. But now you can have 3 separate pieces, and then you 3D print, or you use the welder to weld that piece together, or you 3D print the connector with arc welding or something like that, and you have that part that much cheaper, and then you don't have to spend as much or waste as much.
Yeah. I mean, just one more thing, that we're going to move on to today's topic, but the other thing that they're using it for is prototyping. Because with prototyping, I think me and Nick touched on it a little bit last week, the cost is very expensive to have somebody to use a CNC process, or if you have to use carbon fiber or something like that, you can make the model, see if the model fits. If it's no good, you throw it away and do another one, or you could take that piece and break it down and recycle it if you wanted to. But they're using that with molds now. Molds, Foreign Labs is real big in the molds right now.
And the thing is, you're also seeing a lot of like the guys from Universal Robotics. The big thing is everybody jokes around with those guys because you see all this is a tube, for their cobots that they have. But they've been the industry standard when it came to cobots for crap. What, 10, 15 years now? They were like the first one on the market, I think, or one of the first ones on the market. But they were also the first ones to put one on an AGV and actually tend to SLS printers. So to pull resin beds off of printers and change the resin bed out, bring it back to a processing area and repeat the process. So the thing is you see the guys who've been in the industry for a while supporting the new guys coming in and stuff like that, and it's funny because you kind of see how like Universal Robotics is changing how they do things as they continuously evolve from just the robot arm on a table to being a mobility system, being added to an AGV to pick and place parts and pick and place product in storage containers and stuff like that, put on racks and whatnot. So you pretty much have it's an AGV with a brain, pretty much. It's not just going from one point to another point, following a little, line in the middle of the road. But, if you think about it, that kind of segues into what, this week's topic is about is, do you go full automation or do you go partial automation? And, and I think there's a secondary column you could add in there is, do you try to not do any automation at all and stick with cobots for assisted technology? Because, and, like holding clamps and stuff like that, things that pick heavy things up and for people to be able to work on and stuff like that. Like you're dealing with like engine blocks and stuff like that, you can pick up and hold the engine block while you're putting it together if you don't have an engine stand, or stuff like that. If you start thinking about it, putting tires on cars, doing any of your sanding and stuff like that. But the thing is, you see it from different ways, and that's that's the other reason why I bring up Universal Robotics, or UR, is when we start thinking about them having a robot arm on an AGV to move lot equipment around. So they're moving, once-use or multi-use containers from a supply point to the cell for the human to go in and put the part together, right? So if it's doing the milk run, it's going out there and it's replacing everything inside the boxes, and off it goes. The thing is where would that fall? If you start thinking about it, full automation or semi-automation?
It still would be semi-automation.
I think it would be semi as well. I mean, we're kind of comparing the two, just to see what, I guess, more efficiency as well is one of the big topics. Is how do I produce more? How do I maintain my production line? How do I keep it supplied? We've said it before. I mean, resources are vital, right? So if I don't have what I need to make the product, I don't have the product.
Right.
So if the goal at the end of the day is to push as many of the product out the door, I need something that can ensure with more reliability that something's going to happen 80% of the time, 90% of the time.
Mm-hmm.
If you look at that human may have been working there for 20 years, right? But something could happen that day. They need to go be with their family. You don't have that worker anymore. In a lot of these situations, a robot does fix what you're missing there, and if it's a tedious, repetitive, and in some cases unsafe situation or movement or anything like that, then robotics, that's your answer. Automation is the answer, but I think that cobots should be more of what manufacturing gets to, depending on the size of the product.
Mm-hmm. So that's what I was getting ready to say when you bring that up, is which one do you choose first?
So
do you choose a full-blown industrial robot?
Mm-hmm.
Do you go to the cobot? Well, now, what is it, the CR series from Fanuc? They have the heavy lift cobots now. So, or do you start really moving some of your more dangerous lifts to like a CR series Fanuc?
So the way you determine how to buy a robot or a cobot is very simple. A robot is meant to be something that's series production that a human can't do in the tact time. Ergonomic can't repeat the motion.
Mm-hmm.
A cobot is something that you are taking an application that you want to take off of a human. For example, sanding. For example, car tires would not be a good example because I can use manipulators or I can just use a robot and it would do all of that without having a cobot. The cobot is meant to be not necessarily hey, I'm helping the human. It's meant to take this part of the task from the human and do it over here. So it could be an application where, hey, I need for someone to pick this item up and put it over here.
Yeah.
So what a human can do and what a robot can't do at the moment, until we get things that are more human-like, is a robot cannot sort the same way a human can. A robot cannot pick up screws that are millimeters.
Yeah, object recognition, things
You know,
like that. Yeah.
it just doesn't have it doesn't have the movement to be able to do that over and over. I can give you an example. We use an application where we check the bonnet, the hood, and there is a bolting application. If the bolt does not sit right, a human still has to go in there and verify that the bolt's in place. Because this is end-arm tooling on a robot, but they do not have the fine touch of fingers.
Yeah.
So there are some things cobots can't do. So we know there are certain things cobots or robots are not going to be great at. But the thing is, so to get back, how do we distinguish? Robots are going to be series production. A robot, it doesn't add value to have a cobot when I can have a robot that has more reach, can travel faster than a cobot doing welding. It doesn't make sense to have a smaller robot
I think that's the
for
key
certain
right there
applications.
is speed, because like it's repetitive, fast actions, and because as a human, okay, you might be able to keep up with that robot
For a little
bit.
while,
For a little bit.
maybe an hour.
Yeah, you'd be tired. You need to eat. That robot don't need to eat.
And,
Yeah.
You know, it's kind of funny when we start really talking about this topic. You know, as far as full automation versus semi-automation and stuff like that. You really think that the semi-automations, like full automation, you're aiming for large manufacturing companies. You're aiming for those companies that have resources. You know, they have those resources. They have disposable resources if they need. But your semi-automation, you start looking at your small mom and pops. For example, you know, you have some people who are using, like, especially like I've seen it where you got like bike shops, where you know, for like the race bike guys, right? They come in, they bring them in, and people are using cobots to lift the bicycle up to be able to change the tires and stuff like that, so they no longer have to be lifted up off the ground by a manipulator or a human being. You know, and the thing is, you got these small paint, you know, applications for some of the other guys, you know, that are doing collision repair, doing all the painting and stuff like that. I guess some of the robots on there. So, you know, it's kind of funny as we see the change from, you know, full automation on large manufacturing scales like car plants and, you know, washing machine plants and all the other stuff that needs to, like CNC brakes and stuff like that you're dealing with. You know, and then you start dealing with, you know, your small mom and pops where it's like, okay, cool, we may need a cobot to, you know, help with packing, you know, moving boxes around and stuff like that, because, you know, Sally Sue hurt her back or something like that, and we got to move, you know, boxes around, you know, and stuff like that. So, but if you think about it, that's also where we see that first promotion, like we've talked about, in a small business, first promotion of somebody being moved into a robot engineer spot. You know, that now they're in charge of that robot. They're tending that robot. If you have a welding robot, they're your weld instructors, your weld engineers that are now in charge of that robot. You know, seeing a promotion in their career growth, seeing how they move forward, opening up more doors for school and education for them. You know, as far as in their trade path.
Yeah, I think it's a progression. I
Yeah.
think like, so back to like, you can use cobots in painting unless they're intrinsically safe. Probably not being used.
Yeah.
Now, if they're intrinsically safe, so basically intrinsically safe means that you're using xeno barriers, and the xeno barriers clamp the voltage so that when things cut off and cut on, we don't get an arc. That's what we mean by intrinsically safe. And also pressurized chamber with sensors that can tell if you lose pressure. It stops the robot. In any type of hazardous application where you got a gas that's explosive. But that doesn't mean that you can't use the robot in an application that's where I'm doing, you know, cutting out pieces of metal. You know, so I've got an application where I need to cut out this part 50 times. So instead of a person having to get a torch, the robot can do that. Okay, another application would be small palletization.
Yeah.
So I got small things I need to palletize. Maybe it's a recycling thing. Maybe I have these blocks of aluminum that I recycle at a certain amount of kilograms, and I need to stack them a certain way on a pallet. So that would be a good application. And then I think what I think is the right progression, instead of throwing a person that has no engineering background into an engineering role, they should become a subject matter expert. You should invest in education to help that person if they have the skills. Everybody doesn't have the capacity to become an engineer. So that's why you have a specialist. So even if the guy can't get to an engineering role, he can get to a specialist role. And that's basically the guy that works hand in hand with the engineer every day.
Yeah, no, that makes sense. The palletization, that's a piece that like, this is where kind of the topic, I see it first, right? So you brought up the topic of, Sally Sue is stacking these things. Ed's talking about palletizing in small batches, things like that. These are things that happen every day, several times an hour, several times every couple minutes, probably. Someone stacking something in a warehouse. So in those situations, this is where I am curious if full automation is better versus cobots. I think always you're going to have some type of interface that you have to have with the truck driver or whoever's delivering the supplies. But internally, we who's to say you can't have a AGV programmed to bring everything there? I think still going to be some capacity for humans because you need to make sure that people are following paths. Not everything is packaged the same, so things will break, things will shift, things will have situations you'll have to overcome. But that's the place where I originally would say, yeah, full automation. I don't want to do any of this. This is dumb.
They do have saran wrap robots. I've seen those.
There you go.
They do.
Yeah.
They'll palletize them. Usually, it's a cobot or a light duty robot that'll palletize them, but the pallet is on a skid.
Yeah.
So it slides that skid forward into a enclosed cell where an actual robot is there to actually saran wrap the part.
And which, like I said, they've had machines that do that. I worked on some of those machines.
Yeah.
The thing is, you have to look at cost. So if you're talking somebody that has a small business, the cost of a robot, you have to look at ROI.
Right.
And the ROI, most people are not able to get into full automation.
So you'd say that
you
they
got
have to.
cost is a big factor when
Yeah.
we start talking about when we're talking small model businesses. It's a cost restriction. There's a window that you reach. So what you have to look at is the AGVs. You don't have to have the line that most companies do because it's the cheapest. It's the cheapest thing you do.
It's a cheap insert into automation.
You can do other
follow
systems.
the magnet or something like that. Yeah.
Well, you can do other things. There's other things where you can use Echo. You can use, you can have your own GPS, so to speak, with Wi-Fi, with a mesh system where it knows based off of signals where to go, blah blah blah.
Sonar and whatnot.
Yeah. So that's affordable to a person because a mesh network is not that complicated. You would just have to have somebody that has some experience, or the owner themselves take on the initiative to learn some of the things on how to use microcontrollers. How can I use Arduino, or how can I use Raspberry Pi, or maybe I just go straight to the source and get my own microcontroller and build boards. I mean, like you got places like Exometry that you can send everything to. There's AI packages out now that
PCB stuff like that.
yeah,
You can build your stuff. Yeah.
but there are AI packages out now. You could tell it I need a circuit board for a 5 megahertz repeater, and it could basically, you tell it what parts you want, and it draws it for you. So it lays out all the components, which is, to me, that's excellent. As long as you verify, the human, the subject matter expert must verify that these things are where they're supposed to be.
And the thing is to learn some of that stuff. If you think about it, iRobot, yes, the vacuum cleaner people, they actually have a DIY system that they have built now that they sell to people so they can learn how these AGV, sonar based robots work.
Yeah.
There's so many, academia, resources out there right now about how to build one of these things. And it's at this point, jumping into your first automation project, and that may be an episode that we talk about later, is what is your first automation project when you start thinking about jumping in automation? Should be AGV. It should be material movements from point A to point B. Once you can get that down pat, then we can start working about palletization. Then we can start worrying about, all the other stuff, because, if you don't have your flow down pat, then there's no use. Like, for example, if we institute a pick and place robot or a pick robot at a plasma cutter, right, where we load the steel, cut the parts, yank the parts with a robot, set them on a cart. We now still have to deal with a human pushing the cart, unless it is now a AGV based system that is on a push pull system coming from another station. So that's why, if you start looking at, how do you automate? How do you debate if you're going to go, quasi automation to full blown automation? Is start with your logistics processes first to move things before jumping into a robot if you can.
Yeah.
Because things may get a little easier.
Once again, like I said, that's excellent if the person has the resources, but if you
Right.
don't have the resources, then you use low tech.
Right.
So I think the solution, when we're talking small business, all I'm saying is I think it's a combination. Say if we fully automation can look different. Fully automated can look low tech with AGVs, with cobots, with MES systems, with whatever you want to add into that loop.
Right.
So to resolve an issue of a human having to push something somewhere, if we're talking cost, we could put a system in where we basically load one time. The person one time loads 50 pieces. 50 pieces go into a loader, and the loader auto load. So in some cases, maybe it's better to have an auto loader than to invest in the AGV. Maybe. I'm just saying,
I would say that could be
if
your first
cost is a concern,
Yeah.
if cost is not a concern, and you're not a low level but a mid level, and you're, doing big volume with like Amazon, or you're doing big volume with some company, then it makes sense. Like if you got a print farm with several printers, it makes sense to have that AGV technology.
Right. And the thing is, do you remember, the crash carts? I call them crash carts.
Yeah.
The little buggies, right? I saw this at Automate. I thought it was absolutely awesome. Somebody has found a way to automate crash carts with a bolt-in system that they developed and stuff like that. They also sell their own crash carts that will go from station to station, depending on how you have it programmed, and it'll also help support like maintenance teams that are moving parts from one spot to another. You load the part, it go, send it on its way, and it learns where it's going at all times. But the thing is, that's what you're talking about. You got low tech. I've now taken a crash cart out of all things and turned it into an AGV. It's you don't have to be a robot scientist or anything like that to develop a low tech solution for a company, or for your own company for that matter. If you have a little bit of fun with it, you kind of dive into it and you kind of watch throw a little bit of money at it if you have to. But the thing is research, learn, and figure out a way to make the employees' lives happier and easier and stuff like that. Or find one of the guys or gals in your shop that have a kind of a background in technology or something like that. And say, hey, why don't you take this project and have them now lead a small automation project. And make it homegrown. Have them develop it, have them build their own product, have them do all this other stuff. Like you said, because the thing is, now you have more pride in it. People will be happy to work on it and see it. They'll want to build more.
Right.
And now, you got all these people that are proud of what they do, and they're going to want to see more of it.
Yep.
And then you're not letting people go because you're automating. You're moving people into a design and a research methodology to see how can I bring these robots into my area. How in the world do you think Flippy came about?
Yeah, like I said, then we're gonna let John weigh in. So it depends on if your company
Patiently
is,
waiting over here in the corner.
Yeah.
10, if your company's 10 people or less, then you probably don't have the resources to do some of the things we're talking about.
Right.
You have to lean more on low tech. But if your company is 30, plus employees, then you are considered a pretty big
mid-size.
small
Yeah.
business. So I think that the model has to be based on maybe it's a guy, he only has himself and his son, and then he doesn't have the resources depending on what he's doing.
Right.
So, but if I got a lot of people got print farms and it's 2 people.
Yeah.
So maybe there, because it's 2 people, you can invest a little bit more. Maybe you take out a little bit bigger investment, and ROI with the AGVs makes sense for something to go around and do the tending for you,
Right.
machine tending.
Yeah.
So I think that could work, but in general, it's really tough when you're below
Yeah.
10 employees.
I think it's hard to avoid cost, right? I mean, we've talked about it before that technology is getting smaller and smaller and all that good stuff. That just means things are more available, but that doesn't necessarily mean they're cheaper.
Oh, no.
Yeah, so when you get all these extra bells and whistles, it ends up coming with a bit of a cost. So I think unless you're a very large company, it makes no sense to go full automation. There's just going to be a lot of time spent on the front end of getting it running, and then what's the plan afterwards? You're going to be 100% automation. You're never going to go down. You'll need to figure out some preventative maintenance plan. We've talked about checklists and things like that. So you're already on the part where I think I need a human back, right? So in a lot of these cases, it's much more difficult to, let's say, go full automation. I firmly am in the side of a semi-automated environment is going to be the way of the future. The robots can't necessarily, I mean, it's easier now that we got machine learning and AI for them to adjust and recognize objects, stuff like that, but they still can't do it as precisely as a human does. So there always is a need for an auditor or something like that. Even if your robot's doing a quality check with the light system, like we saw Ignition doing, even if it's doing cobots, like Yaskawa actually has some cobots that they released in when cobots about 6 years ago, when they first started becoming huge, and people were like, we can work with them, or they were curious, and this was mostly in China, where they have entire, almost like how we have cubicles here, working in areas. Like each cubicle was a person and a cobot working on either another project or something like that. And then they go into another building, and it's a bunch of robots building cobots. So it was pretty funny to see kind of the full circle that goes there. You're using one to build the other. You use the other one to make yourself efficient, to make the other one obsolete. So it's like an endless little.
And that's
So
when you start
ABB
getting-
does that now. They've been
Yeah,
doing that.
ABB was a big
They
one
built
too.
their own, not cobots. They built cobots too, but they built their own robots with robots.
And
Yeah.
you think about
Yeah.
it, you start getting into that's when you start running into that really weird world of like what Neuro Robotics does and the cognitive robots.
Yeah.
And you're
Slowly
you're
erasing that line between.
well, the thing is,
Sentient.
well, Neuro Robotics, they took
Skynet.
that line and went, well, there's the eraser, and there it went, and I won't lie no more because
I'm gonna tell my robot it's a person.
literally, I think they did that. But because the thing is, the robot has voice recognition. The robot will look at you if you say, "Hey, robot," it'll look at you. It's like, really?
Yeah.
But and it's
kinda
like
scary.
your teaching is with a camera. It's like, here, go here, okay, and so you don't have the pedal anymore. So your programming of the robot is now, well, guess what? I'm just going to poke, until it figures out what the heck I want it to do.
See, once again, that's old because at least 10 years ago, that
Yeah.
same technology they was using welding with Fanuc.
Well, see,
Right, the touch point robots.
I'm,
What
I'm
are the
thinking
touch
about.
points, right?
I'm thinking about.
Okay, it is. I guess you consider touch
Yeah.
point. You would take the robot and you move it,
Yeah, you move to point to point.
and it moved. So that's nothing new. And then as far as the cobots, Yumi.
Yeah.
I think
Yumi was one of
that's
the
the one I
first
was talking
ones.
about, yeah.
It wasn't the first one, one of the first ones. And when you're talking behavioral robot, Kismet
Yeah.
from MIT was one of the first. And the Japanese has been doing this for the last 20
yeah.
years.
Oh, yeah.
They've been dealing with the emotional or the cognitive robots for a long time.
You think about so voice recognition. It probably has, you were talking about some type of camera or visual recognition it's using. That technology was developed in VR and AR much longer, or much before they even thought about putting it into a robot. So, like, what Ed's saying is they've been doing it. Yeah, a lot of
We
these
just
things they've been
finally
doing
got
it,
it
but
to
we
an
haven't.
application
Yeah,
you can use.
exactly. Put it all together and made something out
And
of
if you
it.
take a look at how Nira does it, and I hate to go down this tangent, but how Nira does it with a robot arm, it's actually pretty cool. Because the first thing you do is you initiate the mesh. If you're getting ready to program the robot, you go over to the little touch panel that they've got and hit initiate mesh, and it takes a 3D scan of everything inside of its box, that it knows where it's at. And then you say, okay, cool, I'm now going to teach you, put it in teach mode. If you want it to weld, you will take a pen that you have in your hand and you draw it on, or you take your finger and you draw it on the part that you're going to weld and hit go. It will actually repeat that process over and over and over again until the robot will never get tired. And if it's like, hey, I want you to pick this up and move this over here, it will use the mesh technology and the 3D scan technology to know what you're wanting it to pick up and move. So it'll know the difference between, do I want you to grab a screw, a bolt, or anything like that, and move it from one bin to another. But the thing is that's just showing that, now as all of the development happening and as we're moving from, full automation to semi-automation and back again, and you kind of blur that line when you start getting into a cognitive, mindset of these new cognitive robots that are coming out, because they're partnering with Omron and all those guys, and they're putting these cognitive robots on AGVs. They're also building a 6-foot robot that walks around like a human called For Anyone. So
so normally those applications you talk about, anytime we say teach robots, that works when I'm commissioning something. That works for a person that has no programming skills.
Yeah.
That's who that's for. But like if you work in the weld shop or in any place where millimeters or microns is what we're looking at, then that doesn't work because I don't have time for something to scan something. Mm-hmm. So it works for like if I'm an initial setup, but like for me, I think the future is not some scanning with cameras and stuff. I think the future is taking on the virtual environment where I can do all this stuff 90% based off of a scan that's taken by something that's accurate. It gives me the scan. I can put it in a CAD profile or a CAM profile, and then I can put that into a virtual environment with a robot. Mm. And right now, 90% of your programming is done that way. The rest of it is touch up at the place.
Yeah, I was curious. I think that it makes sense to have some type of 3D scanning. I think a lot of places are going to go to that. But I don't think you're wrong in the sense that some places probably don't have time.
Nope. Well, if we run a production.
Yeah, if we run a production, and it also depends on the product. Is the size of the product. If it's smaller, it's easier. Things like that. But
so automotive. So just to be clear, we're talking automotive mass production. We're not talking like something that where we're making a small part.
Yeah, something like that. Yeah,
that's different. If you think about it, FANUC. If you start, really getting into your, AR world, when it comes down to stuff like what FANUC's doing, FANUC has now got an AR-powered headset that they use. It's an app that you can put on a headset and use it for maintenance and troubleshooting. When you call back to FANUC's help desk and their support line.
It's like a red phone.
Yeah.
Well, I mean, they can see. They can actually
exactly
see what's going on,
and they can show you, hey, this is how you need to repair this and stuff like that, and they can see it.
I think
in
that's
real life and 3D.
Pretty good.
And then also they have a package developed because I'm playing with it. Mm-hmm. Of course, you go to these shows and you kind of nerd out. Ooh, I got to play with something. You become 3. Or just walk with Champ through Rapid.
You're gonna have to. You'd have to like, I don't know. You're gonna have to keep close because like I squirreled the whole time.
Yeah. But the thing is, this is the fun part about it, and and FANUC made it really cool because they actually have a system where if you put the headset on, it puts you on the outside of the cell, so you can actually watch the cell in AR. You can see it in the space that you're in. to make sure that, okay, this robot is going to do exactly what I want. It's going to clear all my spots. And it's all importable from their simulation and processing software. So it's actually really cool that now we've got to the point where before you even buy the robot, before you install the robot, before you do anything, you're able to put on a set of VR glasses and see that in your spot where it's going to sit and make sure everything fits. Because sometimes people forget how to use a tape measure and they don't realize these robots go vertical. Clapping robots is expensive.
Yeah.
When they clap structure,
And
it's really expensive.
And just for reference, that's going to happen regardless of whatever
Right.
you do, because they're work zones.
Right.
So they call them safe zones, whatever. So if you roll into this robot's supposed to do what it's supposed to, as long as it's there. But if it loses where it is,
Right.
the other robot takes off.
No
Right.
access.
But that's sometimes it's easy
And
to kind of-
we see that sometimes. Most of the time, it's human intervention. Or when I mean by human intervention, it was a human.
Human
90%
stepped
of the
into a
time,
manual.
99% of the time, it was a human error.
Yeah.
The human error, they did not program the safe zone, or they jumped past the safe zone manually and then put the roll back in automatic at 100%. That's normally when you see that.
Yeah, they jump up. They try to jump. You try to jump start the process back over by skipping the part that it failed and making it think it did it already.
You know, the robot.
And yeah, you're not really fixing a problem. You're
Well,
You're
hopping.
creating a new one.
Yeah, oh, you'll get another problem.
So I'll put it in
You fix
terms
what, bro?
that,
Yeah.
that you guys have had experience
Fix.
with. Okay, hey, I have a process in a 3D print that I'm doing, and at some point I have to stop.
Yeah.
I have to stop because I'm going to put a bearing in place.
Mm-hmm.
And then it's going to 3D print around this bearing. However, if I'm not careful, I can get layer shift because I didn't stop it right.
Yeah.
It's the same thing. You can't, it has to go to a point that it knows to go to the next point. If you skip said point, then it's going to go offset from the point that you're trying to send it to.
Yeah. No, that's true. I mean, honestly, we talked about it before when a few of us have ran out of filament. What do you do in that situation? Some people have the bright idea of sitting at the extruder and trying to feed in the next spool at the same rate so that it makes sure there's no difference. Other people have a nice filament runout sensor.
I've got one. I just have not installed it yet.
So it stops and you can switch it out without having any problem.
It's actually sitting on the
Or maybe you have maybe you're a guy with a bunch of money, you got a dual head system, and you got the same filament on the
You
second
got
head.
that Prusa XL going with the
Whatever it is you want to use.
Yeah, the
Everybody
extra
can
bolden
pick their
tubes. There you
everybody
go.
can pick their own flavor.
You got the fancy new
I,
tools.
Yeah.
Hey, I'm not promoting anybody. I'm 3D printer agnostic.
That's what they call it.
I'll take a Prusa XL.
Yeah,
That's all
me
right,
too.
yeah.
It's but the thing is, I think that especially with that new AR based programming, AR based evaluation,
Yeah, that's the future.
from these companies. The thing is, if you think about it, now it gives people who are robot consultants and stuff like that the ability to go into some of these small mom and pop shops and show them exactly what they're asking for, and then they'll be able to tell you, no, that's not what I'm looking for. This is kind of what I want.
Right.
And you give them exactly what they want. They're paying for exactly what they think they need, and stuff like that. They can see it in the spot of where it's going to sit. They understand that where a person is and where a person's not, and they'll understand how far it is away from the power run, the data runs, and stuff like that before it gets to it. I think that hopefully we'll see more and more and more of these companies come out that are going to bring this stuff forward. For example, one of the 3D systems now, you can import any robot on the planet at this point and simulate it. And go through full simulation path and stuff like that. So robot simulation is becoming more widespread, but we need it to be in the semi-virtual world so people can kind of play before they buy.
Well,
Yeah.
I think, like I said, some of the stuff we used CATIA and Dilemma. Some of the stuff when we were doing our, hey, this is what we think we want. It would get, this is what we need to sell to do. These are the amount of jobs we need. We want to have 80% utilization, so we got another 20% for the future growth. You're never going to get to 100% utilization.
Yeah.
It's just in automotive. I would say in automotive. In other industries, they're able to get as close to that as possible. But to me, and it's just going off just a little bit on tangent, the problem that we have with most of these technologies when we're talking, small companies, is the cost of the software, the cost of the hardware, the cost of the consultant fee, the cost of the installation, the cost of the commissioning, the cost of the upkeep. So I think the same way how the microwave went from being a device that was, developed by the military to now it's a commercial thing for consumers that, hey, you can buy a microwave for less than $100. The cost has to be reduced because we're working in a residential environment, we don't have the same things that we have in an industrial environment.
Right.
So maybe we can reduce the cost by, okay, well, this one doesn't have to be as robust. Okay, instead of servos, maybe we could come up with a hybrid stepper motor instead as an option. And it does the same thing. We see several people that have CNC routers and things that they use these hybrid steppers in drivers. So maybe that's a way to cut the cost for the 10. Of course they're not gonna want to do the 10.
Yeah.
So I would say the 30 and up. Maybe that's the way to cut the cost a little bit. And it's a market that you can go into. It's just changing some of the components.
Well, that's a big thing though. Like if you bring the cost of the robot or the cobot down, and it's helping make you produce that much more of a product, it just makes sense.
And don't be afraid to buy reconditioned robots. You can save a lot of money just buying something that's reconditioned. It may be used, but it's still got some serious life left in it.
Yeah.
Make sure when you're buying it that the controller's still supported. In case you need updates or anything like that, unless you want to run it offline completely. So you have security patches and all the other fun stuff. But the thing is secondhand robots and stuff like that is a way to save money and bring automation into industries where cost is an issue. You can see where you can go buy full blown full size KUKA robots and stuff like that now for what, $7,000 with a controller. They may need they've been kind of reconditioned. They may need a new coat of paint, but they work. But then you have the smaller robots out there that people have and stuff like that. Epson's. You have some of these companies. Hell, Epson's making an all-in-one robot right now that they're selling for what, $14,500, I think it is. So don't forget to look at the smaller companies out there that are making robots.
Like I said, it once again, that's if you have somebody that's knowledgeable or do it yourselfer, they're able to do that. But like I know how complex robots are because I've been dealing with them for most of my adult life, and they're not really easy to deal with.
How was the first robot?
Well, the first robot I encountered was, like I said, was ABB, so we had 5400s, and then we moved on to other robots. But I'm saying those robots are very sophisticated.
Yeah.
So even on the secondhand market, you still have to have the software. So if the
software
software doesn't come with the robot,
yeah.
So that's what I mean by maybe it's a solution to where these companies can make a do-it-yourselfer thing, or maybe it's a company that can fill the gap in between industrial robots and cobots, to where, hey, I can get something, that's a little bit better than a regular cobot, and it's a little less than an industrial robot, kind of like our Arduino created their own PLC.
Yeah.
Which is awesome.
So a microcontroller, and they building industrial PLCs.
Yeah.
And the thing is this goes out to the fact that I'm going to grill the big four at the moment. ABB, KUKA, Fanuc, and Yaskawa, and then you can even look at some of the other ones out there that their price of software is outrageous. The good thing about ABB, it's free, literally.
Yeah.
However, if you want to do any simulation and stuff like that, you have to pay a price behind it. It's, if there needs to be you have all these professional robot organizations out there right now. Why don't people come together, think about it for a little bit, and come up with packages for small business? Well, they're not as much for your yearly cost. Maybe if you're a licensed P, it's only maybe $500 for the first couple of years before it goes up when you start seeing a return on your investment. To get their software, to be able to, be in that ecosystem and stuff like that. Come up with, getting started packages, to make it easier to transition even into the older robots, and provide, discounted rate for training for some of the, newer companies coming on the market that are wanting to invest, and even your older equipment, because that itself is still going to get your name out there. They're doing free marketing for you. Not they're going to say they're grind off your name on the side of the robot. They're still giving you free marketing when anybody walks in the door.
Well,
Yeah, some people do.
I mean,
Some people give it a bad name.
Yeah, yeah, Dur does. But the thing is when you go into these places, it should be a discounted rate on software for startups. It should be a discounted rate for training for startups, because the thing is, once you see these STEM startups, people are more than willing to jump in. And the thing is that'll get more people interested, and get more people interested, get more people interested, and you start seeing that growth. And then maybe one of those companies, who that startup that other company supported, will help bridge that gap that you were talking about between full industrial and cobot.
yeah.
Because of the support of the big five.
Yeah, I think the problem is Microsoft made a bad example, and everybody tries to follow Microsoft
It's only going to get worse.
footprint when it comes to software. But I maybe one possible solution is AWS or Azure, and you just pay for how much you use.
Yeah. They're going to rent a Mac now, but you can rent a Mac online and then go.
Whatever. I mean, like,
No
hey,
more
here's a
CrowdStrike,
web-based,
please.
here's a web-based
Yeah.
It's not renting
solution,
downtime.
and you can use this amount. So maybe that's a solution for a small business.
Yeah.
You
I can
just
see that.
pay for what you
Yeah,
use.
infrastructure as a service type situation,
I
or
mean,
something like that.
I know all of them starting to move towards that, to cloud-based
Yeah.
services. So, but they want you to do a subscription.
Yeah.
Now, if the subscription is based off of how much I use, then it's okay.
Mhm.
But if the subscription is you got to pay
No matter how much
$1,500 a
you
month, yeah, that doesn't work.
It's like, I think, what is it, Kuka Cloud, not Kuka Cloud, but ABB Cloud is what, $3,500 a year?
Well, but that's not too
But it's
bad.
not bad if you.
I mean, but how many users?
That's per user.
Oh, yes, that's
Okay, well,
It's I can put it on a laptop cheaper than that.
Yeah.
And go from there, because what your local license is, what, $1,500 a person. And
Yeah.
that's only because it's housed on their software. Jesus.
Yeah, to me,
So
that's the
much.
problem. That's my biggest gripe with all these companies. You should give the software away.
Yeah.
Just take the cost and put it into the robot instead of, or wherever you need to offset that cost. You should want people to use your software. You should want people to use your product. If you're pricing people out of your market, then okay, you're stuck with one market. If that market crashes, then what are you gonna do? You should
crash.
diversify your company some kind of way.
yeah.
And the thing is, if you think about it, look at ROS, Robot OS. It's an open source system for robot control for some of these platforms.
Right.
Not every platform's been cracked yet. I know they're still working the ABB side of the house. I think they might have finally cracked Fanuc. They have 100% support from the guys from Yaskawa. Yaskawa jumped in bed with these guys and supported them from Jump Street. And it's something that rides on the controller, and it allows open source control of the robot and everything like that. But it's still maintaining safeties. And you can use the same ROS to build your own robot, to build your own AGV, to build all your own stuff, because they run on a microcontroller. And with that, it's free programming software, free this, free. It's it's open source, and it's developer supported. And I really think that, especially when you start talking about small businesses going semi-automated, the use of open source robots. You know, the 3D printed yourself robots. You know, and, you know, throw some additive in there. You know, 3D print your own robot. Throw ROS in it. There you go. Bada bing, bada boom.
Even if they can't, the price point is different. So they could have a person that has that knowledge, do it for them at a lower price point.
If you have some, you know, the thing is I guarantee you, I can almost put money on it, that in most of these small little mom and pop shops, somebody in there's got a 3D printer. Somebody's in there with you know, now everybody's got a Bamboo Lab. Well, maybe until Stratasys gets their way. But
it won't matter. It's in China, and then
exactly. They can't do anything about it. So
they wasted their time.
That's true.
But the thing is, it's you have somebody in your shop who's got one.
They'll just change the name from Bamboo to something else.
If I say, hey, guess what? Can you print this for me? But I'm going to pay you for all of your time. I'm going to pay you for all of your material. I'm going to pay for all of your stuff to do this. And let's print robots for the shop. Now, this dude is now making secondary income from his primary income source.
Yeah.
And then, you know, if another shop sees it, another mom and pop, hey, can you print me a robot? And then he becomes the robot, well, I guess you could say robot 3D printing manufacturer. You know, and then somebody becomes the ROS guy.
Yeah.
You know, and it keeps everything inside. It's now how you do robot rep.
Yeah. I mean, like I said, unfortunately, I work with small businesses. I work with a guy that's doing vacuum cleaners, and they don't necessarily have those type of resources. If you're talking 30 and up, yes, that applies. But normally, if it's 10 or less, they do not have the resources to do that, or have the time to pay somebody to do that. But the 30 to more, you know, like that like I said, that areas that's growing. Some of the people that's doing printer farms, some of the people that's doing laser engraving, some of those people are in that range that they can do that, and they already did some of the technology stuff themselves, which is exactly what you're saying. I just want to make sure that we, you know, make sure that people understand that, you know, that 0 to 10 is a little bit different than that 30 to up.
The thing is, if you think about it, like what we were talking about when we're talking about the older robots, the robots that, you know, need to be loved again, you know, given a massage. You know, those type of robots may be a good candidate for ROS. Now you've brought the controller back to the 21st century, and you know, your programming's easier now. You know, so that's a good way to recondition old robots. Install ROS. You bring in the open source ecosystem to robots that were once forgotten about, and, you know, sold for scrap or whatever, and bringing them back. And the thing, so you're kind of recycling the robots back and forth. You know, new software, new hardware.
Yeah.
You know, you may have some if it's not a full reconditioned robot, you will have a couple parts get replaced here and there. But the thing is most of the time you can find those.
Yeah, and it's no different than people getting old, you know, machining equipment. It's the same thing.
And we see that everybody. I can tell you one person who's ever had a CNC lathe, stand up lathe, that doesn't love the old ones because they're more accurate than the new ones.
End mills.
Right. So, you know, and they're getting love now by people putting the open source control systems on them, and, you know, stuff like that. So, you know, it's time that we see that come to the secondary robot market, which can benefit small business.
Yeah, like I said, it's definitely like Champ said, it's definitely a market that's open.
I think that a big piece that we haven't considered as well is that the population of, like, if we broke it down even into countries, because we've been kind of bringing up countries here and there, but at the end of the day, if you look at even our population, the baby boomers that are growing, they're getting older, they're not able to do some of these tasks as well. You bring cobots or robots in to do these things, and you maintain production as well. But I do think it stands to reason that we need to not only take care of these robots, but we need to train the next generation coming up of what the possibilities are, because they're going to get lazy if they don't know. We did this because we didn't want to have to do this tedious thing. They're going to take it for granted. So we have to make it a point to continue the teaching and continue the passion.
So it's I don't know. You might not have been around. You probably weren't around either. So in the 80s, it was a lot of electrical engineers that lost their jobs because the market got saturated with electrical engineers. So a lot of people went into different fields. So that's when we started to see people going to computer science. We started to see people going to ergonomics and stuff like that. So what's happening now is they went away from trade schools, and most kids were, going. So only when I was in school, only 20% of all the kids that were in my school were going to college. So 80% of the other people were going to work in a factory or not work or go to jail or whatever.
Something else. Yeah.
Not trying to be negative. I'm just saying it's just facts. So what's happening now is kids are now saying it's not worth going and getting $100,000 in debt for a 4-year bachelor's degree when I can go make the same money in technology. I can go into automation and controls, I can go into robotics, and those guys will make way more money than most electrical or mechanical engineers, unless they go into certain fields like if you work for the power company, it's a little different. You work for oil and gas, it's a little different. If you work for aerospace, it's different. So it's certain fields that you get top pay. But in general, most mechanical engineers are not going to make near the money that a regular maintenance guy make if you count the overtime.
Yeah. So
the thing that's happening now is kids are now wanting to go more into cybersecurity. They want to go more into they're going away from programming a little bit.
Yeah.
Specifically web design. They're going more towards like automation platforms. But
Python and all that.
Yeah, just anything with automation, like automating server things, administration stuff, networking side
I
stuff.
see a lot of like GPT prompting, like
That's a thing now.
Yeah, so you're technically coding how you're inputting to control the output of maybe an image generator or a video generator or something.
You're an AI coach.
But that's a big thing now. Right now, it'll go away, but for the next 5 years, that is a 6-figure job right now.
And think about what you and me saw at South Tech. We were up there. The big push now to bring back the trade schools. We're seeing that same with Greenville. Their Greenville Tech and other areas that they're pushing. You got all these other companies that are jumping on board, giving these guys a hand. You even have the 4 universities stepping out and supporting the trade schools, or they have a trade school of their own.
And they're also going to a online based thing also, so people that do want to do the 4-year traditional don't have to be on campus.
Yeah, and it's also you got guys who are doing if you do a associates or a trade school degree in mechatronics, they can transition that to a 4-year degree in robotics.
Yep.
And now if you think I just found this yesterday that Purdue is now going to bring in a master's of robotics. They're also bringing a PhD with a concentration in robotics. So now we're starting to see more people pushing the higher levels of education for robotic studies. Yeah. So you got guys who started as mechatronics engineers that are now robot that have a possible path to be a robot.
So unfortunately, the guys that get those degrees are not working in a factory.
Right.
Those guys are working for a manufacturer. I'm just telling you because I know these guys. I work with some of the guys, doing several projects, several $1 million projects. And the thing is kids don't want to go to school for 4 to 6 years because there's no benefit.
Right. But the guys who are doing like mechatronics through the technical school, if they take that and if they want to move further in life, they can.
It's possible. It's always possible. You're right. There are always partner programs, and that's correct. But what I'm saying is that's the problem now. So that's why we have a problem with labor. It's because we're trying to push people into something that is not necessary. I don't need 10,000 robot engineers. They've already figured out 90% of the stuff wherever that robot's being made. We need the focus to be on the artisans that are out there in the field working on the robots. We need those for the guys that's commissioning the robots. That's where the gap is. And I'm all for higher education. I'm not saying anything's wrong with higher education. It's just not for 80% of the people that go to school. What
Yeah.
do you do with the 80% of the people? We're getting off topic.
Yeah.
How do we get that 80% back into the labor force so that the guy that's went to school to do these things can do his job? Because people understand he doesn't have to water down his stuff for a kindergarten.
That's where SME comes in handy.
Yeah.
You know, and that's what we saw in South Tech. Is SME's getting involved and finally
Yeah.
saying that, you know, we're going to advance the trade
Yeah.
school education to make the guy who boots on the ground
Yeah.
smarter, faster, more agile. You know, and give him the tools that
Yeah.
he needs to succeed in the long run. And you know, you're giving these guys, you know, is how SME puts it, and how the guys from Greenville Tech are putting it, is you're taking literally a 4-year education and shoving it down somebody's throat in 2 years, and making them the most competent robot technician that you could possibly get in that amount of time, and give them every
Right.
single tool that's available. And you're giving them SME, you know, getting them involved in the SME organization. That those guys are the same guys who bring you Rapid TCT. Those are the guys who bring you South Tech, North Tech, West Tech, you know, and all these other things. They're bringing the guys who bring the show in education to the masses. You know, it's that you know, and that type of stuff is stuff to get involved in and make sure that
Right.
you know, especially as an organization, you get involved in that to support what they're
Yeah.
pushing.
So
you know,
there's the key. You just said SME is this portion of the solution. The solution is the manufacturers and these companies have to invest in their communities.
And the good thing is I think that, you know, SME, and I can't remember the one that they used at Rapid, not at Rapid, but at Automate. You know, they have their foot well, they got their hand on the pulse of the companies who are doing this, and you know, getting these companies involved, because you see these larger companies that have, you know, giant, you know, education resources built into them now for, you know, lower education and for middle and high education and stuff like that across the board. And you know, one of their big breads and butters is right there at the technical school and below. And you know, for that, one of those companies right now is Yaskawa. You know, they've jumped in and pretty much taken the entire education system in Ohio by storm.
Yeah, but like I said, that's good. Those things will grow, but it has to be not just a Scout. It has to be Allen Bradley. It has to
Yep.
be Siemens. It has to be Omron. It has to be Cutler Hammer. It has to be all of these people that has to say, hey, community, I need this right here. Because in 5 to 10, I would say exactly 10 years, I won't need a guy with a 4-year degree. The technology will be so damn smart. He knows physics hasn't changed. If I teach a model, the physics on this planet has not changed.
No.
With the normal, I'm saying the normal physics, the physics that we got from normal physics,
Newtonian.
not superconductors, not things that we're doing.
Newtonian, classical.
Yeah, just classical. That hasn't changed. If I can take that knowledge from those guys and teach it to a system, I'm not saying it's going to replace the guys, but it's going to make it unnecessary. I don't need that guy. I need a guy to be the SME to this system.
You know, and I think you're onto something, and we're going down this rabbit hole. But you know, you're onto something, and I think that as you see the more progressive companies jumping involved and giving a hand and stuff like that, you're talking about those companies that are, you know, here, let me, you know, pucker my butthole for a little bit because, you know, they got nothing else but want to gain money. You know,
Tesla, prime example.
Yeah, and the thing is, it's like you have all these robot companies who are jumping on board with, you know, trade school education and stuff like that. And for some strange reason, I don't know what it is, the PLC manufacturers, the robot vision manufacturers, where the hell are you?
Yeah.
You know, oh well, we're too good for that.
Except for your
What?
Scout.
Yeah,
Your
except for-
Scout,
well, the
Scout
thing
is
is
an exception.
Yeah, and the thing is, I think you have Yaskawa, you have Kuka, you have ABB, you have Allen, and you have the, you know, well, Fanuc, you know, involved in Kawasaki now, surprisingly. You know, involved,
Well, they're pretty big.
Right.
Kawasaki's pretty big.
But you have them involved in trade school education. The problem is where the PLC guys go.
Yeah.
You know, where the vision system guys go.
Well, but now Siemens.
Yeah.
Siemens right now. I mean, and then we're gonna get back on track. I'm sorry, I took us down a rabbit hole. But Siemens
Yeah.
actually have a web-based free certain courses you can take online from basic programming with S7 products to TI Portal, and then they also have like just motor controls and some pneumatics and stuff. Also, you can go to sites like Festo.
Yeah.
They offer a lot of free information on the Festo website. So there are some things, but you're right, it's lacking.
And you know, I think that you know, as we move forward with things, we're gonna see hopefully that come to life, and you know, see more people kind of, you know, hey, guess what? Let's jump in here, give everybody a hand. Especially like you said earlier, with the advent of the new microcontroller PLCs, you know, popping out there. You know, they're the price point of those things for people to learn them, and the fact that they're giving away free PLC training to learn how to program these things.
Yep.
You know, off their website. You know,
About $200.
yeah,
200 to about, if you get
2 to 6 if you
if you get the
trainers.
stuff, yeah, if you get all the
Um,
IO modules and
Yeah,
things like that.
But the thing is you know, that gets people more interested in them, and that
Yeah.
gets people. You know, you may have a kid who gets one in middle school and says, "Oh, I want to learn this stuff."
Yeah.
You know, because I had an Arduino. You know, now they get an Arduino PLC. They take the courses online. They learn how to do this. Then they go, you know, go through trade school, learn how to work on robots.
For a school, I mean,
Right.
that's
Exactly.
for less than $1,000, I can get one of those and set it up. I don't need but one
Right.
to train a class.
Or if the thing is think about it. You're paying less than $3,000 to outfit an entire classroom with one per table.
I mean, I'm just saying that for me, that's a good thing for, you know, like I said, you don't need all the bells and whistles. For me,
Right.
I think you can get just the PLC, and then
Couple
you
buttons and you're done.
and that's less than maybe $300 with taxes and everything. That's
Yeah.
something you can say, well, hey, I want 5 of these.
Yeah.
I can get 5 of those set up, connect those to each other, and people can talk to each other. I can program this one to do this and that. I can cut on lights. I can do whatever I want to do with it. I can use IoT,
Yeah.
you know, because that's built into it.
Yeah. Wireless is coming soon. On that.
Yeah.
I was really when I played with one, I was very surprised with what it was, the size of it, and the fact that it's so it's action packed for what it is. It's very powerful for the size of the thing it is.
For something that was
Microcontroller
for a kid
right?
to learn to become what they're doing now, that's
And
pretty remarkable.
You can do structured text, you can do ladder logic, or you can do the regular Arduino programming logic.
Yeah, and I think you can use some other languages,
You use
maybe
Python.
Python.
Yeah,
Yeah,
Python
so I
can be
think
used
you
on it.
maybe use Python. But
It's really cool.
yeah,
But again, if we keep going down this rabbit hole, we'll be here all night.
so let's get Champ to get us back on. So
Oh, we've already covered all the topic.
Yeah,
the,
we've already.
the question
Well, no,
was asked earlier. Should we be full automation, or should we be a semi-auto, or what capacity should be our automation or cobot integrations?
So what's the criteria? How do we form a criteria for people to take to say, hey, this is how I determine if I fall into this category?
You've said
or
it
that
like
category?
6-7 times already. It depends on cost. It depends on size of your company. It depends on what you're making. What's your resource pool on the supply chain itself? Like how many things do you need? All of these things are going to be what you need to consider in order to think about if full automation is the solution for you. Because at the end of the day, you're still going to need maintenance workers. If you go full automation, there's absolutely no way that you'll be full automation indefinitely. You have to have a plan for preventative maintenance.
Yeah, I
You have
agree
to
with you.
have checklists and things like that in place. I think that we've kind of danced around it. I don't think full automation is the answer. I think that somewhere in the realm of 70 to 80% automation versus maybe just cobot implementation, 70 to 80% of your workforce there could actually be pushing or assisting your humans there. And
I think that's about what most plants are.
yeah. So even with if I take and look at the plants even just around us, we're in the 80s.
Yeah, that's what I'm saying.
We're not even close to being where we're talking about
yeah.
all of this. We have some robots, yeah, but that's just because I can't pick up a van. Can you pick up a van?
Well, and it's cycle time.
Well,
Cycle
my
time.
spinach, I guess I could.
So
Right,
here-
yeah.
So here's a problem you have with welding. If I heat a piece of metal on both ends, I have the
gonna
possibility
warp.
of deforming it.
Yep.
Right.
But if I heat this robot welds, then this robot weld, this robot weld, and this robot weld, if I do that in such a pattern,
Yeah.
then it keeps the metal from deforming.
Yeah.
And
It
it's
doesn't
easier to
turn into a
coordinate with two robots as opposed to two
Two
people.
humans.
Yeah, so yeah, I mean these things all make sense, but this is something that we decided and found out like I was saying in the 80s. So
Yeah.
so going forward into the future, if we're thinking about continuing production, we're talking about increasing our output. Yeah, you're gonna have to not only rethink the production on the ground level, but you're gonna have to think of it on the digital level too. So the cobots being there,
Yeah, I think-
adding machine learning and AI and all that stuff, that's something that's going to be vital. But that person's going to still need to be there, because not only will they tell like the IT team, hey, my database is crashing, I'm trying to get this robot doesn't know what to do because it doesn't have the data, and then you can now have this conversation and you kind of bridge the gap into the digital world.
So that goes into the Industry 4.0 stuff. So
Yeah.
Industry 4.0 would be able to foresee these things.
Yeah.
Because we would have had a model that we would have been studying, and that model from the data that comes directly from one center of truth would
That's a
be
whole
telling
other
us
rabbit hole.
would be
Yeah.
telling us those things.
Yeah.
In real time.
That's a whole other rabbit
Yeah.
hole.
I mean, I think the thing that we're working with at work, it shows, if you look at the data points, you can see the changes being made and how it affects the whole system too. So like as
Yep.
long as everybody is like aware of those things, and then they can test on a small scale, then yeah, try it out. See how it goes.
Stop pushing the red button.
Let the robot push it.
Push button maintenance never works. You know, but
Well, we'll see in the
You'd be
future.
surprised.
well, we like making noises with our
I mean,
robots.
the button might be have intelligence in the future.
Yeah.
you go try to press the button, it moves. It's like, no, it's not ready yet.
Or just be like, nah, conditions are not right.
Yeah.
Nah.
Well, can we speed that up, please? Because we're playing patty cake with the robots.
Invalid input.
Try again later.
Yeah. It's just
But I think that brings us to the end tonight. We kind of went a little over, not by much, but just a little bit. But the thing is, I want to say thank you to the 2,850 people who've actually tuned in to listen to us freaking ramble. It's, I guess you could say, we began this whole process with a little bit of hope, and we see how things went, and it seems people enjoy it from all over the globe. And the thing is we hope that y'all enjoy it, because we enjoy having fun with it. We hope everybody keeps learning something, and that's kind of something we want to bring is keep bringing new bit of knowledge every day. Go take a look at the website vulcanara.com. Go take a look at the YouTube channel, Vulcanara Technology Solutions. And go out there, Printed Heritage, if you need anything there. I did find a way for us to kind of redo some of that, so I'll be working on that a little bit later. But, and also Vulcanara 3D, hopefully we'll get, with a new logo we got now, hopefully we'll get some merch made and stuff like that, and ready for people to get, if they want it. But, the thing is I say thank you, and, I hope everybody, is being safe, healthy, and having fun, and always learning something new. So, y'all have a good one, and I'll turn you over there, boss.
I pretty much echo the same thing that Nick said. We appreciate all the support. Appreciate you guys listening to us. Maybe we can get some feedback on if we want to do a live episode with you guys where y'all can,
Like a happy hour.
maybe y'all can, tell us what you want to talk about, and we just kind of just go by that. And thank you for your support.
Yeah, I'm always appreciative. And what is that? That almost 2,900 there. That's what's that? Less than 3 years. less than 2 years, I would even say, or right around 2 years.
Yeah, right at
That's
2
that's
years.
pretty impressive. I didn't think that we had gotten that high, actually, to be honest with you. But it's easy to say when you're not staring at the number the whole time, right? I don't see it, but every few times. So it's a good feeling. I hope everybody is getting at least a nugget of knowledge out of something in one of the episodes. And if there's anything you don't understand, the only way to know is to ask. So if you don't say anything, you're just gonna say not knowing. So just reach out if you have anything you're curious on, anything that you heard and you're like, hey, I don't know if that's quite right. Maybe we can chat on it, and maybe we are wrong. I mean, sometimes we're human too. Sometimes we could be wrong. So let us know what you're thinking about, what you liked, what you didn't, and yeah, stay tuned.
Yep. All right, y'all. Y'all have a good one.
Yep.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.